Hello and welcome to SoundcheckPro. Today we'll be looking at the Maggie mixer, which is the first mixer in the selection to open up all of the available features in SoundcheckPro. SoundcheckPro is a training simulation that helps you get up and running working with professional sound, making it easy to understand what all the knobs, buttons, and switches do. All of the destinations common to signal flow can be found throughout the software. SoundcheckPro presents the console window on the left-hand side and the external rack window on the right side. In the external rack window, there's a Patchbay that displays all of the inputs and outputs in the environment that we could route to and from. Above the Patchbay is our time-based effects, such as reverbs and delays. Below the Patchbay are the dynamic processors such as compressors and EQs. Multi-track recorders are located at the bottom. Regardless where one is working, audio sources are going to be a part of the equation when mixing and recording. Sources could be microphones, electric instruments, or even audio files from your computer. In SoundcheckPro, we can configure sources in the Sources window. Because SoundcheckPro is a simulation and there isn't always a band present to work with, we use audio files to represent audio sources, and we can designate their source types. Select an individual file to be added or drag and drop a selection of files to be spilled out onto all the tracks. For this demonstration, I'm going to clear all the files and use the demo file that's included in the software. Verify you have signal output from the Sources window on the meters. It's important to get things right at the source. Any unwanted artifacts or noise introduced to the signal at the input will consequently be there throughout the signal path. Notably, the difference between mic and line signals. A line signal is significantly louder than a mic. A microphone signal requires a preamp in order to properly boost the signal to line level without introducing noise to the signal. We can visualize this by looking at the meters. Our line source is outputting at around 0 dB. But watch what happens when we select a microphone. The signal is greatly reduced, to about -40 to -50 dB. This might be different depending on the audio file or source that you're using. Regardless, we're going to need a preamp to properly boost this signal to line level. With our source connected to the mixer, let's begin setting levels. First, let's clear out the microphone so that we are working with a line level signal that is coming out at around 0 dB. Now, you wouldn't be wrong to assume that the sources are directly connected to the mixer. However, there's a very important stage in between the sources and the mixer, and that's the Patchbay. Patchbays represent all the inputs and outputs in the environment that we can route to and from using patch cables. The first row of the Patchbay is for the mic panel and file player, in this case, the Sources window. The second row is the channel mic line input, which can be found here on the mixer. For a matter of convenience, when there is no connection on the front end of the first two rows on the Patchbay, an automatic connection is made on the back end. We call this half normal. We can disengage this. When disengaged, we would have to connect the cable. Simply click on an input and an output for a cable to be drawn between them, and shift-click or right-click in order to delete the cable. This is useful if you would like to reroute your audio to appear on different channels or to include external processors before entering the channel. All of the external processors, such as the reverb, delay, compressors, etc., are located on the bottom 2 rows of the Patchbay. Let's begin setting levels. The source is currently connected to the line input on channel 1, and that feeds the input gain knob. We want to measure the levels after the input gain stage without anything else in between. We can select solo to override the output of the mixer and the meters. In order to visualize what is being sent to the solo bus, head to the master section and select PFL for pre-fader. This allows us to see the signal levels coming in on channel 1 just after the input gain. Notice the signal levels reaching 0 dB as it is leaving the source's window. They should be near the same. Now, watch what happens to the signal levels when we change from a line signal to a mic signal. The signal level is now so low that it is no longer showing up on the meter input. For channel 1, we're going to have to boost a signal. Sure, theoretically, turning up the input gain knob will boost the signal. But you'll see for something that's cranked all the way up, we're not really getting so much power out of it, and we are consequently raising the noise floor using this process. What we can do is switch to the mic input, which will go through a mic pre, therefore boosting the signal much more significantly and without raising the noise floor. Now you see we're reaching higher levels, even potentially clipping. We don't need to go that high, so let's back off a bit. Now that we have set our input levels, it's time to reach the output. Let's disengage the solo functions that we had just used. Raise the channel fader, and assign the output of the channel to feed the LR main mix. That will feed the master fader, and the master fader feeds the main output. We can actually verify that signal is reaching the output via the Destinations tab. By default in SoundcheckPro, we don't listen for the main output of the mixer. Rather, we're listening for the monitor source that is selected. Each board is going to have some sort of monitor source with a headphone knob or monitor volume. This is how we monitor and listen to SoundcheckPro by default. Alternatively, you can change the observable output in SoundcheckPro at any point. This is an ideal way to preview mixes that are not solely relying on the main output. Notice the vDAW meters below. The vDAW is a virtual representation of a DAW. In SoundcheckPro, it merely serves as a destination receiving input and immediately outputting the signal. In this case, the input to the vDAW is coming from the direct outputs on the mixer. The direct outputs are what follows the channel fader. Regardless if it's assigned to the main output of the mixer or not, signal will be received at the vDAW. Visualize this by disengaging the L and R switch on the channel to remove the channel from the main mix bus. Let's look at the rest of the channel strip on the mixer. We'll reintroduce signal for this segment. Maggie has a 3-band EQ, each band with a gain parameter. However, the mid-band is the only one to offer a sweepable frequency. The low filter has a switch to adjust between 2 predetermined frequencies. Just below the EQ is a button for inserts. Inserts allow you to incorporate external devices and processors that may not be built onto the mixer so that they could be included in the channel signal chain. By enabling the insert at this point in the channel strip, A slot opens on the Patchbay for the channel insert to send signal out to an external device. Look at row 3 for insert send. And then comes back in at the insert return at row number 4. This is useful so that we could use any of the devices in the external rack. It's important to note that not all mixers will have an insert. Some mixers may activate their inserts upon the connection of a cable at their insert ports on the back of the mixer. The pan knob adjusts the spatial positioning of the channel in the left and right main mix. Notice when the signal is panned hard to the left, that the opposite signal on the right is gone. The same goes if panned hard to the right, that the left signal diminishes. There are different panning laws that can be found on various mixers, so you may notice other behaviors. The channel fader consists of a fader for levels and several other assignable options, including mute solo like we had seen earlier, and the bus assignments for the main mix. We can also assign subgroups 1 and 2, and 3 and 4. Let's disengage the main mix so that there is nothing feeding the master fader or the master meter outputs. Assign channel 1 to subgroups 1 and 2, and raise the faders for subgroups 1 and 2 to unity. Each subgroup could be assigned to either or both of the left and right outputs. In this case, assign subgroup 1 to the left and subgroup 2 to the right. Notice when panning hard to the left, that signal is no longer feeding subgroup 2. And the same for the opposite panning to the right, the signal will no longer feed subgroup 1. Subgroups are used to process a collection of sounds together as one. The volume of all the sounds in a group can be controlled by a single fader. Additionally, the subgroups' outputs are being sent to the Patchbay. They could be routed into processors and returned onto an open channel or input. Below the input gain is the aux FX sends section. FX sends are used to send a copy of the signal towards the master section or output of the mixer. Sends are ideal for headphone mixes or for creating effects chains. There are a total of 6 sends per channel with 4 knobs to control. Aux 1 and 2 feed a master gain in the master section. Raise the aux end and the aux master gain for aux 1 and notice the activity on the meters in the destinations window. By default, sends are post-fader, meaning they are sent after the level of the fader. If we reduce the level of the fader, notice the aux levels are no longer being received. Assign the sends to be pre-fader so that they are listening for signal before the level of the channel fader. This is how you make an ideal headphone mix where the send levels are independent of the channel levels. We can observe aux 1 as a headphone mix by selecting it in the destinations window. Auxes 3 and 4, 5 and 6 do not have a master gain control knob in the master section. Their outputs feed directly to the ports on the back of the mixer. If you raise aux 3 and aux 4, we could see them immediately on the destinations window. Aux 3 and 4 could be shifted to aux 5 and 6 with the shift button. The auxes are sent from the mixer to the Patchbay at the aux FX section. Let's create an effects send that goes to an audio processor. and returns onto the mixer. Let's turn down aux 4 so that we are only using aux 1. Keep in mind, we still have the pre-switch engaged, so our send levels are currently before the fader. Send 1 is going to the send master gain in the master section, which in turn is coming out of the patch bay at effect sends 1. Let's patch into the S delay at the left input. This effect send is mono. This device is prepared to handle a stereo input. If we look at the device, we need to power it on in order to visualize signal or for it to even work at all. Many time-based processors will include a mono to stereo switch in order to compensate for the mono. Now the signal is processing in stereo. Let's adjust some parameters here blindly, but enough that we know the signal is going to be heard when we bring it into the mix. So now we have two ways to bring the signal back onto the board. Either use an open channel, or, even more practical, is to use the effects returns in the master section. In the case of effects ends, let's use the conventional stereo effects returns, and that has its own section on the patch bay. Here, we'll come out the device from the left and right outputs and then plug into the stereo effects 1 input left and right. That is going to be located on the mixer in the effects returns section. To verify that we have signal, we could disengage the subgroups bus assignments going to the left and right main mix. In fact, let's turn them all off. Disengage all the busing. Now when we are working with the returns, when we raise the effects return gain, we will see signal on the meters. And if we turn up the monitor volume, we'll hear some nice reverb or delay or whatever we're using. Not all the stereo returns work the same. If we were to return onto stereo return 3, there are more options presented to us. We could turn up the effects return as normal, where it feeds the main mix at the master fader. Or we could route to the subgroups like we had done before. Now when we engage the subgroups into the main mix, we'll see the signals. In order to really complete this process, we want to blend the original source with the wet signal. So I'll assign them both to the same group and doing this a little blindly right now. But we're going to want to adjust the effects return and the signal that's coming from the channel fader so that we get a nice stereo image with the effect. Alternatively, the effect sense can return on open channels. Adjust the input gain and the channel fader gain stages. To better visualize this, let's disengage the subgroups that we created and assign the outputs of channels 3 and 4 to the main mix. Blend the original source by assigning channel 1 to the main mix. Thanks for watching.